Well, let me start things off by welcoming you and thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, if you're a college professor or an industrial trainer teaching programming skills required in manufacturing, maybe you're a company looking for ways to demonstrate your software-based solutions, or maybe you're even someone looking for ways to make IoT-related concepts easier to understand to employees or to customers. If you fit into any of these categories, I really do believe this presentation is going to offer some important options for you to consider. I'm going to start off today by considering the skills gap. Now, if you've attended any of our other fischertechnik education webinars, you probably heard me discuss the importance of STEM education. And STEM, of course, is the acronym for science, technology, engineering, and mathematics. And it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Of course, not so long ago when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics or industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions we're going to be looking at in this presentation, let's just stop and consider that last skill area I just touched upon, that of being a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is also an acronym like STEM, and the letters in this case stand for Programmable Logic Controller. Essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes that are typically found in an industrial setting, and these will be places such as an automated manufacturing plant. As the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. And to get a clear picture of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. And to quote the site, the average PLC programmer's salary in the USA is $78,000 per year, or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at a list of current job openings for PLC programmers on nuvu.com, and this would have been for February of last year. And at that time, the listings were showing 15 positions being advertised with salaries of over $75,000. And 2 of them even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time, as this workforce of tomorrow is seeking their own training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools, which offer such programs. So how long does it take to learn PLC skills? Well, depending on the student's background and experience, very basic programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, such as you see listed on the screen right now, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are also many other options available. There's high school CTE, career and technical education programs. There are adult continuing ed programs. There's vocational training, technical training in trade schools, and also employer-sponsored incumbent worker training programs, as I touched upon before. Now, that all being said, the question that still arises for the educator, and that's whether it's the educator in the university or the vocational school classroom, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands-on? But there are also other areas of focus beyond programming that need solutions for demonstrating and exploring and understanding different aspects of automation and control systems. Now, it could be, for example, a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes, which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Or it could be a manufacturing company that's looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course there are more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, both in appearance and function, various automated robotic machines and systems commonly found in commercial manufacturing. But before we look at each of these models, let me just provide you with a little bit of background on what fischertechnik is. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, based upon their unique building system. Now, what makes this building system unique is that unlike other popular construction systems where the components are designed to simply stack, with the fischertechnik system, it was created with more of an engineering mindset. What I mean by that is the core building block in the fischertechnik system is designed to enable attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help to address very specific design needs. The fischertechnik system was developed back in the 1960s by German inventor Arthur Fischer, who's also noted for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949. And he's also credited as the creator of the expanding nylon wall plug, which is, of course, used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in the automobile assembly industry, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Once again, the focus of fischertechnik sets, and that's whether we're talking about those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Now, many of the products offered by fischertechnik for the education sector are subject-specific sets. And what I mean by that is there are things that focus on different STEM-related areas, such as mechanics, pneumatics, robotics, or perhaps new renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system, and then they perform various experiments which allow them to explore and understand different aspects of the given subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deeper into engineering and about learning all aspects of the design process. And this requires them to work in groups and to create various devices and create various automated machines to meet the criteria that are put forth in a series of real-world scenarios that are being presented in the curriculum based upon their own trial and error experimentation and research. But what we're looking at today, the line of fischertechnik simulation solutions, these are something much different. This line consists not of kits, but of a series of pre-assembled small-scale models which are designed again to replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line include things such as conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models, which will focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. The model consists of 4 of these individual workstations, in this case, a vacuum gripper robot, high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which are all designed to work together as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using fischertechnik solutions. Now, I will apologize in advance, as the first few points are things that I've touched upon already earlier in this presentation, but I think in each case it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, and this is both in appearance and function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because these models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of these models is available in a 24-volt version designed specifically for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you use Siemens controllers, or if you use controllers from manufacturers such as, for example, Honeywell, Mitsubishi, General Electric, or many others. You can control these 24-volt models with the PLC of your choice. Likewise, just as you can use your choice of controller, you can also use your preferred programming language. As you see, the 5 major languages that are listed on the screen, whichever variation you prefer programming in, if it's structured text, if it's function block diagram, etc., you can use that. Now, please note that with these 24-volt models, no PLC is included, and all programming and programming guidance, as well as any power sources or any other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are again designed specifically for industrial users or for those teachers who are involved in teaching and exploring industrial processes involving PLC programming. Now, in addition, for non-industrial users and educators who may not be as versed or familiar with PLC programming, there are also several models which are currently available in 9-volt variations. Now, these 9-volt versions ship pre-wired to fischertechnik's own proprietary robotic controller, which is called the Robotics TXT controller. And in this case, each of the controllers is pre-programmed using fischertechnik's own RoboPro graphic programming software. With the 9-volt models, the only additional component required will be the addition of 1 or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these models should be ready to use right out of the box. Now, if you're involved in demonstrating and exploring IoT, which is of course also known as the Internet of Things, besides the fact that many end users have adopted or adapted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik also now offers a special IoT-focused version of the factory simulation model, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. And we're, of course, going to discuss this in detail later in this presentation. Finally, fischertechnik simulation models are cost effective. Now, if you've had the opportunity to look into any other hardware-based industrial simulation options which are available in the marketplace, you probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of that price, as well as being, again, compact, realistic, and high quality learning and demonstration tools. So on that note, I'm just going to grab a sip of water and we will begin a look at each of the models which are available. First up is the vacuum gripper robot. Now, as you're going to see in this video, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model you're going to see is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you'll see in the video on the robotic arm, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt versions of this model, as well as of all of the first 5 24-volt models we're going to look at today, each have a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions, will require you to provide the PLC and the program. And for a limited time, I will say there is a 9-volt version which is available, which is the version that you see it work in this video. And once again, this comes wired to the fischertechnik Robotics TXT controller, and again will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. And I will mention that for this and for all of the models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. The next model we're looking at is the automated high bay warehouse. The model features a transfer station with conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, as well as 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming, and the reason for this is because it gives you a lot to work with. Now, that's in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each of these workpieces, each step of which, of course, will require its own very specific coding. The dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. And also, a limited edition 9-volt version is also available at this time, which again is pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required with that. The next model, as you see, is the multi-processing station with oven. This model features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, the standard version of the model is a 24-volt version for use with the PLC of your choice, which once again has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And the limited edition 9-volt version in this case is connected to two robotics TXT controllers, and because of this, two 120-volt power adapters will be required for all operations. We'll just let this finish up. And there we go. The next model in our progression is the sorting line with color detection. This simulation features a system for detecting workpieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components used on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, you need to provide the PLC and the programming. And the limited edition 9-volt version again comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. And there we go. The next model we're going to be looking at is the factory simulation, which combines, again, as I mentioned, the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection into one self-contained material cycle. And the cycle works like this, as we'll start to see in a second. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with oven. After the work piece has been processed by this machine, it is then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've discussed the components for each of these models previously, I won't belabor it by restating them all here. But what I do want to mention are the dimensions of this model as a whole. As it again combines 4 individual models into one cycle, it has a much larger total footprint of approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt or the limited edition 9-volt version. Now, due to these dimensions, please note that this model can only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. Now, a few other things to note. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. Now, in the case of the 9-volt version, it is wired to 5 robotics TXT controllers, but because of the way they are daisy chained together, it will require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required. Again, each station of the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations we've just discussed, or a couple that we're going to look at a little bit later. And so if you have any interest in, let's say, transporting the model or just protecting it and when not in use, you should strongly consider this. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and an angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds. Now, please note that even when using the travel case, these models will still need to be shipped flat. So moving right along to our next model, which is a basic conveyor belt. Now, this is a transport belt. It has a length of about 275 millimeters that is used to transport work pieces with a dimension of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Now, components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just under 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, in this case, 26 pins with a 2.54 millimeter grid as shown here. And for a limited time, we also have 9-volt versions pre-wired to the robotics TXT controller as shown here. Again, one 120-volt power adapter is required for the operation of the 9-volt version. The next model is a variation of the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except this time with a machining station built onto it. Components on this model include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 15 by 12 by 7.5 inches, and it has a weight of about 3.5 pounds. Again, it's available in the standard 24-volt variation with a 26-pin connector and a 2.54 millimeter grid as shown here. And again, for a limited time, we'll be offering a 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model we're looking at is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts I just mentioned, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of about 8 pounds. Again, it's available in both the standard 24-volt variation with a 26-pin connector and a 2.54 millimeter grid for use with PLCs, and in a limited release 9-volt version, which is wired to the pre-programmed robotics TXT controller and requires one 120-volt power adapter. Next is a variation on the idea of a pick-and-place robot, and this is the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 can turn 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. And again, this comes in either a 24-volt version with a 26-pin connector and a 2.54 millimeter grid, designed for use with PLC in the programming of your choice, or in this case, a 9-volt version, which I should also mention is not a limited availability model. This is something that will be available moving forward in the future. You'll be able to get a 9-volt version. And this again comes pre-wired to the pre-programmed robotics TXT controller, and it does require one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next pair of simulation models will focus specifically on the area of IoT and are designed for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available in both 24-volt versions for use with PLCs and 9-volt variations for classroom and demonstration purposes. Now, these have been designed to help address how the recent changes in industrial production, which are driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version of this model provides a really nice narration overview of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
The following topics can be addressed with the Fischer-Technic Training Factory Industry 4.0. Training and simulation on a realistic production model. In-depth learning through haptic comprehension. Optical and sensory applications. Digital traceability with NFC/RFID technology. Customized production in lot size 1. Integrated cloud connection and control via smart devices. Using and operating dashboards, web-based remote maintenance, the linking of production materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we've previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model. Now, some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enable the positions of each piece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with one another. Now, as there are two variations of this model, let's go over what makes them different aside from the voltage requirements. And we'll begin by focusing on the 24-volt version and what makes it unique. First, it's a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one Fischer-Technic Robotics TXT controller. Now, in this case, the TXT controller serves as the MQTT broker and the interface to the Fischer-Technic cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. Now, this allows the option for not only presenting and using data on a dashboard in the Fischer-Technic cloud, as we just saw with the 9-volt version, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled
via PWM, also known as pulse width modulation. They also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features, unlike any of the previous 24-volt models we've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. Now, in this case, the program is in structured text format and was created based upon a Siemens S7 1500 PLC and is available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small modifications to the sample program. And the source codes needed are also available for download from GitHub. Now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information and much more is included in the 152-page PDF manual, which you usually get access with when you obviously buy these, but you can also download it for free from the fischertechnik website or from our website. If you go to the listing for this product, you can download that manual. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all other 9-volt versions that we've looked at previously today, in this case, these are programmed not using RoboPro software, but instead using C, C++. Again, all of the programming with the 9-volt version is preloaded, so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF also available with this model, you should be able to get started quickly. The 9-volt version will require the addition of 3 120-volt power adapters. Of course, it will require the ability to access the internet, as well as a tablet or a device for accessing cloud-based dashboard. Dimensions for these models are approximately 39 by 31 by 16 inches each, with a weight of approximately 51 to 53 pounds, of course, depending on the version you're using. Now, as with the other 2 factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that's the Training Factory Industry 4.0 model, again available in both 24-volt and 9-volt versions. Of course, you might well be wondering how much these models cost, so let's take a quick review of each option I've discussed along with the pricing for each. First off, the vacuum gripper robot, the 24-volt version, you see the part number up there, currently $974 each. The 9-volt version, part number 536625, is $1,199 each. The automated high bay warehouse in the 24-volt version is $1,099 per unit. The 9-volt version is $1,319 per unit. The multi-processing station with oven in the 24-volt version is $999, and in the 9-volt version is $1,479. The sorting line with color detection in the 24-volt version is $836 per unit, and in the 9-volt version is $1,129 per unit. And of course, I will mention, because I sometimes get asked, how come the 9-volt versions tend to be higher? Keep in mind that they do have the controllers, where with most of the 9 or the 24-volt versions, you of course need to supply the PLCs. Moving right along, factory simulation in the 24-volt version. It is available for $4,029 per unit. The 9-volt version is $5,239 per unit. The conveyor belt, 24-volt version, $226 each. In the 9-volt version, $519 each. The punching machine with conveyor belt in the 24-volt version, $299 per unit. In the 9-volt version, $599 per unit. The 3D or 3-axis robot, 24-volt version, $865 each. And in the 9-volt version, $1,169 per unit. The indexed line with 2 machining stations in the 24-volt version, $869 per unit. The 9-volt version, $1,399 each. And the Training Factory Industry 4.0 model for exploring IoT and cloud-based control, the 24-volt version, $7,896 per unit, the 9-volt version, $7,560 per unit. And other items that I've touched on throughout this presentation today, the 120-volt power adapters, which are required for the 9-volt models, are $12.99 each. And the travel and storage case recommended for all factory simulation and Training Factory Industry 4.0 models. So those 4 separate models we talked about, these are available for $1,000 each. So at this point, if you do have any questions, I will ask you to use either the question and answer window in the Zoom toolbar or the chat window, which is also available in the Zoom toolbar. You can type in any questions you might have. I will give you a second there, see if anything comes up. If not allowing you to take time, if you do type something in, I will address it. But otherwise, how to take the next step? Well, if you'd like to request a full color brochure, and if you'd like to get printed copy of the current pricing, if you'd like to ask questions directly, if you'd like to receive a quote, if you'd like to speak with your dedicated educational representative or anything else related to fischertechnik and fischertechnik simulation models, you can give us a call directly. Our office in the US is at Studica. It's 888-561-7521. That's, of course, a toll-free number. If you just wanted a quote or you have a general question, you can email us at info@studica.com, studica.com. If you have a question specifically for me for addressing anything that I mentioned today, something maybe I didn't touch on that you would like me to, any questions about using fischertechnik simulation models, what have you, you could email me directly. My email is lance.zurich, that's lance.zurek, again, at Studica, studica.com. So on that note, I'd like to thank you very much for attending today's presentation. I do look forward to hearing from you soon. Have a great day. Take care.